Okay, let's continue with the next perspective, which is the cognitive perspective, cognitivism. Cognitivism, as a perspective on learning, arose around the age of 1960. That was the year in which the Journal of Cognitive Psychology was published for the first time, and also the year in which the book by Miller, Galanter, and Pribram, Plans and the Structure of Behavior, was issued. Why is this year important? Well, there are two reasons. First of all, you should understand that cognitivism is a reaction on behaviorism, is a next step, let's say, in our way how to consider learning and instruction. That does not imply that behaviorism isn't relevant anymore. It is a relevant theoretical perspective, so we should keep it in and use it as a very important way to study and to understand learning. But in 1960, a new perspective was born, so to speak, the cognitive shift it was called, and researchers, educational psychologists, learning psychologists tended to think that you could say more about learning than just that learning is a reaction on a particular stimulus in the environment. So here again, the interest in the structure of the mind and the structure of memory and the structure of behavior was born. So therefore the title of the book by Miller, Galanter, and Pribram, Plans and the Structure of Behavior, is important because a new interest was born into how people organize their knowledge and how this organization influences the way they learn. Okay. And the second reason why 1960 is an important year is that that year also marks, or let's say can be placed into a development of the domain of computer science. Computers became more and more powerful, and for instance, the domain of computer chess was developed, which also showed that, let's say, machines can be trained to act and think, if you wish, like human beings. So these machines, these computers, might also be considered as a model of the way in which humans act and think and solve problems, etc. So the computer as a model for the human information processing system was acknowledged in those years, and particularly in the year 1960. Okay, so we move on to a definition, and then we will discuss one particular example, in fact a statement by one influential educational psychologist, David Alzubel, and then we will focus on a particular issue, metacognition, which can be understood very well from the perspective of cognitivism. Okay, first of all, the definition. Now, as you can see here, this definition definitely resembles the way computers operate. Learning is information processing. Learning leads to relatively permanent changes in observable behavior or potential behavior. This distinction is important. Again, it points towards the new attention to processes internal in the human mind. External, let's say, outcomes are of course visible in education. Students start to learn the tables of multiplication, and they can easily answer the question 5 times 4 is. Well, that's a definite external outcome. Observable behavior. But you can also think of changes in potential behavior. Tolman was a famous psychologist who studied the behavior of rats in a maze, in which they were put in the center and had to find their way out to find the exit of the maze. And that took them a while, so they explored all kinds of corridors, and then eventually they found, the exit. Okay, you can do that again and again. So you can put the rat again in the maze, and it immediately will start to explore again and try to find the exit, etc. So that you can do in several trials. Now, imagine that you offer a reward at the exit door. So the rat receives a particular reward, and will easily find the exit on the next trial. So you can see a very, let's say, very common learning curve in which the time to find the exit is reduced on the next trial. The rat learns to find the exit quickly in order to find the reward there, of course. Now, if you compare two groups of rats, one group is being rewarded and the other group not being rewarded, you will see a definite difference in behavior. So the group of rats which is being rewarded again and again on the consecutive trials will start to find the exit quicker and quicker. So you get this learning curve. Yeah? For the group which is not being rewarded, you will not find such a learning curve. These rats are just exploring and exploring, and there is no clear, let's say, reduction in time to find the exit. Well, that makes sense, I guess. But whenever let's say we do that for 8 trials on a row, and then on the 9th trial, you give the group of rats not being rewarded also the reward which the other group already received 8 times before. What you see then, that is the group which had not been rewarded very quickly finds the exit on the next trials to come. So there is something like a very steep learning curve, and very soon this group matches the speed of the group which had been rewarded all along the previous trials. So apparently there has been changed something in the minds of these rats. During the trials they were not rewarded. So what Tolman called, they created a cognitive map, a sort of a mental representation of the maze, and they used that map to quickly find the exit once it was necessary, or it made sense to get quickly to the exit. Okay, so that internal outcome, that cognitive map, you might consider as a sort of potential behavior. Therefore, the difference between observable and potential behavior in the definition of learning. Of course, examples can be given in the school context, acquiring vocabulary, learning English words, for instance, by matching them with Dutch words, or very complex skills like inquiry-based learning, in which students have to conduct experiments to solve a particular problem or to find evidence for a particular law in physics or whatever. Okay, so from simple to complex, you can find examples of this kind of learning in which learning is considered as information processing. Now let's focus on a particular model which has been very influential and still is, which originates from this cognitive psychology point of view, the multi-store model by Atkinson and Schifrin. This model shows how information is being stored in the human mind, in long-term memory. In order to arrive at long-term memory, as you see at the right end of the diagram, information passes to different stores. The first store in which information arrives as soon as it is being observed, so to speak, is the sensory memory, which is a specific store directly located next to the senses like the ear and the eye and the other senses. So each sense is supposed to have a separate store of its own, where information is kept very, very shortly, in the order of milliseconds, but still is being kept there, and you need attention, focused attention, to get information from the sensory memory to the next, let's say, stage, which is the short-term memory. Short-term memory is the place where information is kept for a short period of time, short-term period of time, of course, and the capacity of short-term memory is also restricted, as Miller used to say in his famous paper. It's a matter of the magical number 7 plus or minus 2. So 7, 8 or 9 units can be kept in short-term memory for a short period of time. You can repeat them like, telephone numbers we used to learn by heart a long time ago, before the arrival of the smartphones. But we learned them by heart, and we repeated them, and that kind of repetition or rehearsal is typically needed to keep information in short-term memory. After that, you can transfer it to long-term memory to store it more or less permanently, and you can try to get the information back from long-term memory through retrieval processes. Now, you can also see in this model that the idea of short-term memory is also a bit related to the idea of working memory, the place where information is being, let's say, processed and is being used to find a solution for a particular problem. Okay, so this multi-store model is typical for the cognitive shift movement. Okay, so that was the definition and a bit of the context of the cognitive perspective. Now we move towards one particular outstanding researcher in this domain, David Ausubel. He had a very nice and famous statement, which I think is important and also illustrates, the value of the cognitive perspective. If I had to reduce all of educational psychology to just one principle, I would say this: the most important single factor influencing learning is what a learner already knows. Ascertain this and teach him accordingly. What this statement says is that what the learner already has in his or her mind is the basis upon which new knowledge can be built. So new knowledge and new skills are always built upon existing knowledge and skills, the declarative and procedural knowledge. And when that happens, when it is organized in that way, the new knowledge will also be effective and useful. When new knowledge is just, dumped into long-term memory without relationships to existing knowledge, then it becomes, as people call it, inert knowledge. So it is there somewhere in the head, but you can do nothing with it. You cannot even find it when you try to retrieve that particular piece of knowledge. So knowledge has to be related, new knowledge has to be related to existing knowledge in a network kind of idea. And that is also very characteristic of the cognitive approach, that you consider the human memory as a structure as a network of nodes in which all kinds of concepts and also skills are related. Okay, so therefore this particular example of the cognitive approach. Then we would like to focus on a particular concept which has been developed a little bit later, or well, let's say it was developed out of the ideas of John Flavel, who was an American researcher who translated and tried to understand the work of the Swiss psychologist Jean Piaget, who studied, the cognitive development of children. And Flavel brought those ideas to the United States and developed his idea of metacognition. Metacognition is something like thinking about thinking. That's the basic, let's say, definition. So you can think about the way you think, or the way you learn, or the way you develop skills. And that particular thinking leads you to an awareness of how you operate when carrying out cognitive tasks. And that awareness is a part of what we call metacognition. But you can also use that awareness to regulate, to monitor and to control these cognitive activities. And that's also the more, let's say, procedural part of metacognition, which we consider as part of metacognition. So we both consider declarative knowledge and procedural knowledge or regulation of cognitive activities and learning process as part of metacognition. Learning and knowing about learning and knowing. Okay? The model by Nelson and Narens gives a very good, let's say, concrete illustration of what we consider as metacognition. What you see here is that there is an object level, so the level at which we act and learn and do and perform all kinds of cognitive tasks, where we are active. And there is a sort of, supervising meta level, which controls our behavior, but also monitors our behavior, the progress of our behavior, and stores that particular information about our behavior, our cognitive behavior, in a model which more or less represents the progress we make during the execution of cognitive tasks. So there is an executive level and there is a controlling level which more or less looks after the whole process and tries to bring it to a good end. Now the meta level or the controlling level, that's what we call metacognition. Okay? So we can always make these distinctions, and they are very helpful also when we try to teach learners how to study tasks, how to perform study tasks, how to improve their effectiveness while studying, etc., etc. To make them aware of the way they act, perhaps the way they act efficiently or not so efficiently. Yeah? Okay, metacognition. Now, the concept of reflection is closely related to metacognition, but not only reflection. We see here various types of metacognitive knowledge and skills. I, in fact, already mentioned that. So knowledge about cognitive processes, about the way you study a chapter in a book, or knowledge about the way you develop ideas for an essay and actually put them into the essay eventually. But it is also a matter of skills and strategies, the procedural part, in orienting, in planning and in evaluating. So both unconsciously and consciously. So consciously is what we call the let's say the goal-directed planning of cognitive tasks, like writing an essay. And unconsciously you develop routines in which you apply when, for instance, let's say solving a complex problem, because you have done it so often that you already know how to deal with that. The way, let's say, doctors state diagnosis is an example of such an automatized or routine-like way of analyzing complex problems like illnesses, etc., etc. Okay, yeah. Now, the last thing I would like to discuss is the issue of reflecting. That has been in the Netherlands a very important concept in education, and it has also been studied by Fred Korthagen, a very influential colleague. And you may already have been acquainted with Korthagen's so-called spiral model of reflection. I just took this from a particular website. You can see the reference. And in this model, you can see we start with one, acting, gathering experience, doing things. And then after you've done that, after you've completed a particular cognitive task, you start to look back, to reflect on it, to look back on the task. What did I do? And you become aware, next step, of the essential aspects of task execution. And then you start to think about the execution of the task, and you start to think about alternatives, which you could have, other paths you could have taken, other approaches you could have taken, and you are selecting one of these alternatives and are starting to try these alternatives and see whether that leads to a better execution of the particular task. Well, that is a reflection cycle or a spiral model, as Korthagen labels it, because there is a continuous interaction between acting and reflecting. Yeah, so that is a very nice way to put to put into words, into a model, the way we reflect. That is not, unfortunately, the way it's often done. Reflection can be considered differently from various, let's say, educational contexts. The last of the three I mention here is completing a reflection form, in which students simply have the task to reflect. You have to reflect on what you did. And students usually do not complete such a task in a very, let's say, intelligent way. They do not start to consider alternatives for the way they had completed the task, but they simply start to write something which is like reflection, but not necessarily is a real reflection. And that makes the word reflection a bit, of a problem in, for instance, higher education. Fred Korthagen, he explained when he retired in his farewell lecture that there is a particular Facebook page which has been called by students, "I hate the reflection cycle of Fred Korthagen." So students are becoming very bored by this task to reflect and to think about their acting because of what? Perhaps because that's my idea, and that's the second explanation here. Thinking about acting is, of course, the first one is, of course, let's say, a very proper definition, but it does not say much about how this thinking goes along. My idea is that you cannot start to reflect on alternative solutions, for instance, like it is in the reflection cycle, before you are aware of something which is not functioning in a proper way, an unexpected event. There's something which does not is in accordance with what you expected to happen. And then you start to think about why should this have happened and what is the cause of this problem which gradually arose. And perhaps I can find an explanation and try an alternative way to carry out a particular task. So there should be something like a problem, something like a hesitation, something which bothers you. And then you can start to think about a way to solve that particular problem. And that is what reflection should be. So reflection should be problem-based, I think. And otherwise it becomes a routine or a boring routine, basically, without real content. Okay, so this is all about the cognitive model, cognitivism, and you can, of course, understand that it is a richer approach to learning and instruction than the behaviorist approach is. The behaviorists try to reduce everything, to stimuli and responses. Also in a very, let's say, dedicated way, because they would like to, as Watson was saying, would like to connect with natural science. Now, in this next step, let's say, in our thinking about learning, is that we broaden our scope and we take more aspects into account, like the structure of behavior, like planning, like reflection, like problem solving in a broader sense. And that is what cognitivism contributed to our understanding of learning and instruction. Okay, thank you.